Please, everybody stand up. All right, so hello everyone. My name is Richard Schneeman, or at Schneems. It rhymes with schnapps, sort of. Some people, that's easier. You might know me from such gems as Sextant. If you don't like running rake routes, then gem install Sextant. You'll love it. Or Wicked, it's a step-by-step wizard builder for Rails controllers, so check that out. Also, another little thing I've been working on is issue triage. If you want to help out on, say, like Rails issues, or you just really want to get involved with an open source product, then issuetriage.heroku.com, and yeah, just go there, visit it. So I do work for Heroku. Also, I am an adjunct professor at the University of Texas. So that also means that I have about 40 hours of online videos, tutorials, exercises, and quizzes for anybody interested in learning Rails. They can go to schneems.com/utrails. Write that down. Okay, so I am here today to talk to you about what we learned at Heroku from deploying so many applications. So right now we've got, I think, 2.2 million applications deployed. Basically, our CTO sat down and said, all right, what are really common things that make a good application? What are things? Sure, we tried some things in the past and they didn't work, and we're doing some things now and they work really well. But what are those elements that make up a good performant application? So combined, we call this the 12 factor, which I am here today to talk to you about. And it's going to give you all of these benefits and more. So originally this was a 45-minute talk. I do apologize. So I am cutting it down to a 25-minute talk. So are you ready? Okay. Code-based dependencies, config, backing services, build, release, run, process, port binding, concurrency, disposability, dev prod, parity, logs, admin processes, questions. Yes, you. No. Okay, actually, so Rails got a lot of things right. I'm not going to go into everything super in-depth, but instead I'm going to cover on what could be better. So we're all Rails developers. It works out pretty well. All right, so number one, this works pretty well with Rails, having one application and one code base. So keep your entire application inside of Git. Obviously, we all love Git. If, Git, GitHub, and if you have a library that you need to share in between multiple pieces of code, multiple applications, put it in a gem, put it somewhere that you can easily access it. So some people say, well, sure, I obviously do this, but across all languages, that's not exactly the case. So other people might ask, what about service-oriented architecture? They hear me say one app, one code base. I consider a service an app. So whenever you were generating multiple services, you were actually building multiple little mini applications. You can launch each one of those separately and run them separately. So other people say, well, hey, I need a feature, I need to refactor my code, or I need a new demo, that kind of a thing. I want to copy my code, put it somewhere else, modify it. Don't do that, put it in a branch. Do yourself a favor, if you've not heard of Gitflow, please then check out Gitflow whenever you get a chance, or even better, GitHub Flow. I really like it for working with teams, or even just working individually on my own projects. Help me keep my code kind of clean, and it's a nice open source workflow. In general, if you have a project, you want to be able to clone it and run it. If you have to say, all right, clone these 5 projects and then stick them all in the same folder and then you can run it, then that's no good. All right. Okay, so number 2, dependencies. Luckily enough, in the Ruby community, we've got Bundler. We've got Terrence Lee, the maintainer of Bundler, actually speaking in just a little bit. So I'm pretty psyched for that. The most important thing with this is always check in your gemfile.lock whenever you are pushing to somewhere else. And what this is going to allow you to do is have consistency across multiple machines. So I run bundle install on my machine, and I push it up to my production server. I want to be able to get the exact same versions of the exact same gems. Not just kind of the same versions, but the exact same versions. So pretty reasonable. Okay, both of those were pretty decent. Rails is pretty decent at both of those. One of them that Rails isn't so great at is actually configuration. So what exactly do I mean by configuration or config? So these are going to be the different things that might actually vary in between your deploys. So S3 credentials, Facebook credentials, security tokens, those kind of things. And really, these don't belong in your source control. If you are hard coding your passwords and then you are doing a git commit on those passwords, that's probably bad. You know, you want to be able to ask yourself, can I hire a contractor today, give them my source code, and then fire them tomorrow? Well, hopefully they'll work out and you'll love them and you'll use them forever. But you know, if you can't, then that might be an issue. So secrets in source control aren't secret. And the thing you really want to be able to ask yourself is your app open sourceable like right now? Could you, if you just wanted to, could you flip the switch or would you be exposing security holes? Would people be able to access your private credentials? You know, that's not really good. You also want to be able to ask yourself, can I do things like have rotatable keys? So Rails with session signing and those types of things, we have these hashes or these values that we use to hash for encryption. And if somebody gets a hold of those, then they can spoof attacks on us. So we're not very secure if we just have one static string. So right now, Rails, most people do the config stored in YAMLs. So we're used to like database.yaml, or you know, you'll just create your own initializers and you'll just hard code in a constant app underscore S3 equals something something. So instead, I like the thing I'm proposing is to use environment variables. So these are going to be things that can be read on the entire computer level. If you don't want it to be read on the entire computer level, you can just think an example of an environment variable would be path. Right now, if you're on Unix system, you can just do echo $path. That's an environment variable. So I use a .env file in each one of the projects I have, and I put all of my secret values in environment variables in that .env. And then I use another product called Foreman, so just gem install Foreman. And whenever you run something with Foreman, it will automatically read in that .env, and you will have access to those environment variables. So here inside of Ruby, we can actually access the environment variable that we had set from our .env file. So that's how you would do that in development. So the next question is, okay, well, sure, I might do it this way in development, but what about production? Inside of production, Heroku, obviously we are advocating this, so we actually added a feature called config. So you can do config add and then actually set an environment variable equal to a value. And then just read it from the environment. If you're not using Heroku, first of all, why not? Maybe you're on a VPS, and here is a way you could do that. You could maybe use Foreman, or you could directly add those values to a command. Or if you only are running one app on one box, you could just put it in, say, like your .profile or your bash RC. Some people, when I mention this, they're like, well, I still have to store them somewhere, and that's fine as long as as long as it's not in your main application. It's not a security concern. The next thing I get a ton is people say, well, I like doing this. I like all these YAML files. I am a YAML file addict. And to them, I say, just because something works doesn't necessarily mean it's the best way to do it. So save your sanity and store in the environment. Okay. Backing services. We know we love these things. So what's a backing service? We got our databases. So we've got different data stores, key value data stores. SendGrid might be considered a backing service. We want to be able to treat these things like attached resources. What exactly do I mean? You want to be able to replace or repair individual services at will. So maybe you need more memcache. So you spin up a bigger memcache instance, or you add capacity to that one service. Or perhaps your memcache goes down and you want to spin up another one. Instead of having all of that on the exact same box, if you have those separated out into multiple different services, then you make your system a lot more tolerant to faults. This is going to help you isolate failure. It's going to help you upgrade in kind of a modular way so that you can actually focus on what needs those resources. Okay, so build, release, run, number 5. We're doing good, I guess. We got, yeah? All right. Is the method through which you're actually going to be releasing your code. We want to separate these out into 3 distinct steps. First one of them is going to be build. This is going to be where we are going to fetch any kind of dependencies. We're going to run bundle install. We're going to precompile all of our assets, anything that we need in order to be capable of actually running. So this is going to be everything that happens before you would actually type in like Rails server. When we release, we are going to take the result of that and add it to our configuration. So we talked about having configuration stored separately in the environment. You want your build to be able to run no matter what your configuration is set to. If when you build, it is going to generate a different output depending on your configuration, then something is wrong with your app. Yeah, it's that simple. And then once you've got all that done, then we do the final step, which is run, and there's really not much to say for this. It just, you press go, and it works, hopefully. So this has a couple of advantages and a couple of features as opposed to doing kind of all of that in one step. Say, you know, yes, we were doing this before, but why? Clarify and break it out into those 3 distinct areas. The biggest one is it gives us the ability to roll back. So we separate our build and our config settings so that if we were to change a configuration setting and actually record that, then we could roll back in time and only change the configuration setting back in time, or we could roll back our code in time by using a previous build. It actually also prevents hotfixes. It prevents somebody from kind of going in there and manually changing a file. And sure, that might sound like a bad thing, but that might work well for 1 machine or even 2 machines, but when you get 100 or 1,000, it doesn't really work so well. Okay, so stateless processes is something that we as a community are all about. If anybody is from the Java community, anybody previously? It's okay, I see some hands, all right. You don't want to store state inside of your process. Most Rails developers are used to having multiple instances running on multiple boxes. That's fine. They store state in, say, the database or in memcache. A lot of Java, the best practices from a while ago was to just store it in memory or store it on disk. So in order for, if I am logged in on computer number 1, I have to have all of my requests going back to computer number 1. So if a process has a problem, you want to be able to kill it, and you want to be able to bring back up a new one. Using the old model of saying we're going to store that the process or that state in the process in memory, we weren't able to do that. So you want to store it in the data store and not on disk. So I don't know how many Unix fans we have in the audience or how many JZ fans we have in the audience. So I like to say I got, yeah? All right. I got a couple laughs off that one. Okay, so number 7, port binding. This is, we really don't even need to talk about this as a Rails community, but some people do. If you have friends in the Java community, maybe go tell them, hey, don't use Tomcat. It's not the greatest thing in the world. If you have a web server container that is wrapping your application, that's not necessarily a good thing. So you want to just export your applications as services. And really what this comes down to is binding it to a port and then being able to reach it at that port so other applications can talk to your service directly. And comes down to running it without a web server container. Okay, number 8, concurrency. Scale out, not up. Heroku loves this. We're all about making this process easier. And the great thing is, if you followed all the other steps and all of the rest of the steps, this one's really easy. We're not storing state on disk. We are all about separating out our build and our release and our run. So we can do things like have separate instances for the web connection. So whenever an HTTP request comes in, we have web instances ready and capable of handling that. In order to get more load, we can also have non-web instances, such as workers. We're pretty used to this also as a community. And this is good for sending out, say, delayed emails or using image processing. You might be familiar with rescue or perhaps delayed job. And a general flow is you in-queue something from the web server and then you de-queue and run from the worker. It gives you more capability and more capacity. Also happens to work great with Rails 4.0 and ActiveQueue. Also, this is something that following all of these, it'll make it a lot easier for you to do, even if you're not running on Heroku. Number 9 is disposability. I was not around when they chose the name for number 9. Basically, it means start fast and shut down gracefully. Again, this is one of those kind of a process-oriented factors where we want to be robust against any kind of sudden death. So if your process is going to create any, or open up any locks or modify something on your disk, then as it fails or as it dies, as it shuts down, if it doesn't put yourself in a position where you can come back from that and where you can recover from that and just start up a new one, then you're not going to be putting yourself in a position of where you can come back from that. It allows you to scale a lot easier. It allows you to be a lot more robust in your processes. And I say disposability gives you possibilities. I don't know. Like I said, I was not around when they named that one. Okay, so development versus production. This is pretty important. This is also something as a community that we have kind of embraced, where we have these very specific different environments. We have a test environment, we have a development environment, production environment. I also advocate for using a staging environment, which is actually just generally the exact same as my production. So the big thing about this is you want them to be as close as humanly possible. Even though we have different configuration options for different ones, at the end of the day, you really, really, really want your code and your entire system to be as close as possible. We call this dev-prod parity. So we want to be using the same data stores, we want to be using the same language versions, and I also actually, in addition to that, go a step further, and I like to use real data, or at least consistent data. One way that we could do this is using like PG backups and actually just capturing an entire snapshot of your database, downloading it, and using that as your local development database. Another thing I've done before is having scripts that just automatically, they will use something like Factory Girl and create and Faker and create a whole bunch of fake data. So this is good in if you have a data set that's too large to pull down the entire database. Along these lines, in addition to dev-prod parity, I will say there's actually a developer-developer parity. The biggest thing that can help you with this is your README file, so readme.markdown. Danish was like advocating for this, and like this is like the most important file in your entire project. You need to be able to give your README to anyone else, and they should be able to get going. Like if they can't, then your README has some problems. Every new developer to your team, one of the first commits they should make is to the README file if there were any problems getting set up. You could go a step further and actually automate a lot of these processes and automate, setting up the dev environment, installing different items, starting up your processes, and doing any kind of environment fixes automatically. But by having these clearly laid out, all of your developers know exactly what is needed and what goes into the setting up process. So even if you have that type of a script, I highly advocate for a README. Okay, we're in the home stretch now. We've got logs. Logs are very important in Rails, and they are a kind of first-class citizen. Maybe it's not so great that they store the files by default instead of standard out, but that's a different story. So logging is really, really important because after all of that, errors still happen. And with logging, we want to be able to get to those errors, find our backtraces, and come back and actually figure out what happened. So within Heroku, we've got logs tail. It'll aggregate all of your logs together from all of your different servers, whether you're running one server or you're running 1,000 servers, they're all just in one continuous stream. In addition to that, I recommend using something like a logging service such as Papertrail, and this is going to store your logs and allow them to be searched kind of at a mass scale. So we can actually go through and say, you know, here's all of my logs for the last 3 months. I want to see all the times I came up with this error. There's also other services such as New Relic that I really enjoy that also add additional visibility into what's going on inside of your app. And it's not always just what's in the logs, but you know, they can record common exceptions. And when you see certain exceptions bubble up, you know, quite often or very frequently, when you see those error rates rise, maybe after a deploy, then you know something's wrong. And again, following all of the previous steps, you could do something like just roll back to a previous build. A pro tip that I'd like to add is admin flavored error pages. So this is actually a shot of an error page on my girlfriend's website that she runs. So it's Our School. It allows you to sign up and create custom classes. So if I am logged in and I'm an admin, so there's a current user and there's an admin state on that current user, if I actually hit any kind of errors on the page, actually in production, instead of being a static 404 page, it's a dynamic page. And what it'll do is it'll check and it'll say, are you logged in? Are you a current user? If you are, then we're going to show you, the original error page, but we're also going to add the backtrace to whatever that exception was that you just got. Some people get a little bit confused by this. I don't mean that you're seeing other people's errors. I mean, if you are an admin, you were logged in, you were using the site, and you encounter an error, then you see basically what you would see in development. This just makes things a lot easier, helps for debugging, and then you don't even have to go diving into your logs to figure out what's going wrong. All right. The last one I got going is admin processes. You want to run all of your management processes as just kind of these one-off scripts. An example of this might be rakedb migrate. So the nice thing about running rakedb migrate is it actually forces you to have your code already on the server when you're running it. And we want to be using the same release code. Whenever we're doing this, if we were to go back in releases and run the same script, different things will happen because of different release code. In general, it's not a very good idea to go onto your server and just do things in the console. If it's worth doing on production data, it's probably worth actually storing inside of your project, inside of your process, and recording that. Okay, so I know that was a lot. That was like 12 factors in half the time. So just kind of a quick recap, what did we learn? The 12 factor kind of sets the stage for the current state of Rails, as well as some things where Rails could move towards. And this is kind of important not just for us, but for really all people in the web programming community, because Rails really sets the bar for other web frameworks. If you've taken a look at Play, a very, very popular, incredibly flexible, up-and-coming framework for Java, it looks almost identical to Rails. Almost everybody, that's their claim to fame, is like, we are Rails-like. So things that we do in the future really actually affect not only just us, but the entire community. Rails can definitely still be better. If I have one additional message to give, it would be follow Terrence Lee on Twitter, maintainer of Bundler. Completely unrelated to the rest of this talk, but just do it. Does anybody have any questions? I have 1 minute.
Any questions? I'm really far away, so just speak up.
Okay, it was a Heroku question. The question was, why Postgres? The answer is because Postgres is awesome. So if you want to use MySQL, there's add-ons for that, or you can spin up your own EC2. 30 seconds, go. So the question was, why don't we automatically migrate your database? So that gets into kind of different code concerns and what you expect versus what you need to do for yourself. Sometimes people will check in migrations that they didn't mean to or that they didn't want to run. Yeah, so it's kind of one of those, like, even though 90% of the people want to do it 90% of the time, it just causes more pain than not. I actually personally wrote a script that I can run rake Heroku :deploy, and it will do that, and then it will automatically migrate my database for me. And it also runs my tests and doesn't deploy if my tests haven't passed. So, you know, it's kind of a win on all counts.
Constantine.
Yes.
You said you should just, instead of exposing a web API, web service, you should just simply open a port. And then what do you talk over that port if you don't expose a web service?
So I mean, yeah, you wanna open it up as a web service. Basically, the point of that one was just don't use Java containers for your Rails apps.
Okay.
Any more questions?
All right, so I will be around. I'm wearing.
Question?
Oh, yes, another question.
Continue to the DB migrate question.
Yes.
Do you have any tip for post-deploy actions that the web server will not be available? It will first do the steps of the post-deploy actions?
Post-deploy action.
Custom, like DB migrate, like some rake task that I need to do to migrate data after deploy?
Yeah, so that's something that I've done before is I'll do that. Or another one, I'll actually add the migration as a commit and deploy that and then run the migration. And then after that, I'll add the code so I don't get any errors. And that's kind of a little bit more of a traditional deployment scenario. But that's pretty much it.
Any more questions?
I've heard of people integrating with, like, say, Travis CI, where they will set it up and not deploy if their build didn't fixed. And so I think that's pretty important.
All right, thank you, Richard.